So in this lab, our purpose is to determine the thickness of a sheet of aluminum foil. Since we can't measure it directly with a ruler or other measuring stick, what we're going to do is we're going to find it indirectly through a series of steps that take advantage of the properties of aluminum itself, as well as some mathematical maneuvering with different formulas and the connection between different properties and different measurements and different units. So the first part of this process is to determine the density of aluminum. Now again, we can't do that very easily with the foil because finding the volume of the foil is difficult based on its dimensions. So what we'll do is we'll find the density of an aluminum cylinder, which is much more substantial, and since density is what's called an intensive property, the density of that aluminum cylinder is also the density of the aluminum foil. So again, the first thing we want to do is find the density of the cylinder. To do that, we need the volume and we need the mass. So in this image, you can see that we have a graduated cylinder, and there's the line of the water, the measurement is right here, and we have an aluminum cylinder next to it that we're going to then put into the graduated cylinder. Once the aluminum cylinder is in the water, we can now see that the level of the water went up to this mark here. We started with a graduated cylinder that had some water in it, and we wrote down the measurement of the volume of that water. Then we added the aluminum cylinder, and the water level went from its original position to this new position, and we've written down that measurement to the correct number of significant digits. Well, if we have water in the beginning and water plus aluminum at the end, what we need to do, and we'll do this in the calculation, is find the difference between these two measurements. The difference between the water levels is the volume of the cylinder that we put in. This is known as the displacement method. We're measuring the volume by how much water it displaces. Now that we've measured the volume of the cylinder, we need to take its mass. And to do that, we're going to use an electronic balance, which we commonly refer to as a scale. And this one, the estimated digit is just the last digit on the display, which you can see here. This is the mass of this graduated cylinder. So we have the volume, which we calculated a minute ago. Now we have its mass, and mass divided by volume equals density. So that's going to be one of our calculations. The next part of the process is measuring the properties that we can measure simply with the aluminum foil. And then we'll take the information we gathered about the aluminum cylinder, connect it to the aluminum foil, and again, through a series of steps, we'll work our way from the density to the volume, and then the volume to the thickness. Okay, so the first thing we're going to do here in this part of the process is measure the length and width, which will give us the area of the aluminum squares. So there are 4 of them. I think in our original procedure we had written 5, and that's okay, there's only 4. So take a look at each one of these images, which has a piece of the foil with the ruler marking above it. Make sure you pay attention to the markings on the ruler and record to the appropriate number of significant figures. So I'm going to put each image up here for a few seconds, pause the video if you need to see it more closely or more carefully, and then you can move on to the next measurement. Make sure you keep track of which square you're looking at. So square number 1, fill in your data table as you go along, and then we'll move on to the mass. Okay, so the last bit of data that we're going to collect is the mass of each square of aluminum foil. So as you can see here, we have all the aluminum foil pieces on the digital balance. I'm going to blow each image up a little bit so it's a little bit more clear. Again, feel free to pause the video at each step so that you can take your time writing down the measurements, fill in your data table for mass, and then we'll move on to the calculations. So at this point, you have completed your data gathering for this particular lab. The next phase in the process is to do our calculations, our analysis, and to write our conclusion, which will circle back to answering the original question that we asked in our purpose statement. Okay, so you've now conducted the lab virtually, and then we're going to go through and complete the lab report by doing those steps that we have now that we have our data to work with. Okay, so here we go.